Hello grade 9s, this is Mr. Miller and welcome to lesson 5.1 on the language of mathematics. So for starters, let's talk about algebra. Algebra is a branch of mathematics where symbols are used to represent numerical values which are either known or unknown. These symbols are usually letters of the alphabet, and generally we use the English alphabet, but in math we also use Greek letters a lot. So here's an example of how we can use algebra. Let's suppose that the regular price of a shirt is $30.30, and we want to calculate the sale price during a 20% off sale. So you would have done something like this in grade 8, taken the price of something and subtracted 20% of the price. So that $30.30, we subtract 20% of $30.30, which is $6.06, and you get a sale price of $24.24. Now there is another way to do it, because if you start with 100% price of something and subtract 20% of that price, you're left with 80% of the price. So a more direct way of doing this calculation is just doing 80% of 30/30, and that gives you $24.24. So now let's suppose we want to calculate the sale price during a 30% off sale. Very similar calculation. Start off with the full price, subtract 30% of that price, and we're left with $21.21. The other way to do it more directly is to just calculate 70% of 30/30, because 70% is 100% subtracting the 30%. Again, we get the same answer, but it's a little bit more direct. So now let's suppose we want to calculate the sale price during a 40% off sale. And of course it's the same calculation. You're probably getting a little bit tired of it at this point, but what I want to show you is that if you have to do repeated calculations with the same number over and over, when you know you have to do many calculations with the same number, in this case $30.30, it is possible for most scientific calculators to assign that value to a letter. So X, for instance. Then you can do your calculations by entering that letter instead of the numerical value. So you'd have to press one button, X, instead of having to punch in 30.30 over and over and over, as we had to do these calculations. This reduces the number of keys that you have to punch in, and it saves you time. And this is just one of the benefits of algebra. So here's my calculator, and I'll show you how you can store value in and then use it in repeated calculations. We were looking at the value $30.30. And on my calculator I can press the stow button and then press X. When I press enter, now I have 30.30 stored in as X. So I can take that X value and do calculations with it. So for instance, X times 0.8, what it's doing is 30.30, because that's storing as X, multiplying by 0.8. Notice that's the same result that we got on paper. So we can take that X and multiply by 0.7 now. And we can take that X and multiply by 0.6. And so on. We can do repeated calculations of 30.30 times whatever without having to always punch in 30.30. All we have to punch in is X, because X is taking place of the 30.30. And that's algebra. Alright, moving along. A constant does not change. A constant does not change. It doesn't vary, so it's not a variable. It is simply a number. Some examples of numbers of constants. So 1 is a constant, -2 is a constant. The number pi, 3.141592, blah blah blah, that's a constant. Here's a very special constant in math. You maybe haven't heard of it before. It's called Euler's number. And you might be thinking, Euler? What do you mean Euler? I mean Leonhard Euler. Now this is a very strange pronunciation, I know, but This guy, Leonhard Euler, discovered in math a very special number, 2.7182818. It's also called the banker's number because this number is involved in a solution to a very specific kind of banking question. I won't get into the details of that right now, but I just thought I'd let you know that in math, lowercase e, which the e is coming from Euler, is representative of this number 2.7182818, and it goes on forever. It doesn't repeat. It's kind of like pi in that way. It's an irrational number. And here's another example of a constant number. It is the letter I representing the square root of -1. The square root of -1 is actually an imaginary number. That's why we have the letter I here. But this is a constant. Okay? It doesn't change. It doesn't vary. It is not a variable. It is simply a number. So now, let's talk about the next thing in algebra, a variable. So a variable, as the name suggests, it varies and it changes. And in math, we use a letter as a variable to represent a number. You can use any letter that you like, but you should try to pick letters that make it easy to tell what they represent. And try to avoid using letters like E and I, because as we just saw, they have special values in math. So some examples, if you're going to have a letter representing the price of something, probably you should use the letter P. You can use N to represent a number, Q to represent the number of quarters in a jar, and so on. You could probably think of other examples. Let's go on now to talking about what is a term. A term is a number or a variable, or the product of numbers and variables. So examples of this are 8, that's a number, so it is a term. X, that is a variable, so it is a term. 8x, which is the product of numbers and variables, and so that is also a term. 8 times x times y squared, that is a term. But not any of these. So the square root of x, we will not be dealing with terms like that. Okay, we're not going to include that in our definition of a term. 1 over x, we also won't be dealing with that. A coefficient is the constant factor of a term. So for example, in 8x, 8 is the coefficient. In the term -9y, -9 is the coefficient. Notice here that when a term is negative, the negative is a part of the coefficient. Now a polynomial is an algebraic expression that's formed by adding or subtracting terms. So here's an example of a polynomial. We have x to the 5 minus 6x to the 4 plus 3x cubed minus pi x squared plus 2/3 x minus the square root of 7. So some interesting things to notice here. First of all, we have x to the 5, and you might be wondering what the coefficient here is. We didn't write any number before the x to the 5, but it is a single x to the 5, so it is a 1. In algebra, when the coefficient is 1, it's not necessary to write it. In the next term, we have -6x to the 4. And it's kind of funny because you might think, oh, we're subtracting 6x to the 4. And then you might be thinking, well, I thought we were supposed to, well, I guess we could either add or subtract terms. But you can actually think of this term as adding -6x to the 4. And -6 is the coefficient of this term. So some other things to realize is that pi, or negative pi, can be a coefficient. It's just a number. And you might be thinking, I thought we weren't allowed to divide by things. Well, 2 divided by 3, or 2/3, 0.6 repeated, that's really just a number. We're just not allowed to divide with the variables, or divide by a variable. And then finally, you might be thinking, well, I thought we weren't allowed to take square roots of things. Well, you're not allowed to take the square root of a variable. This is just taking the square root of a number. So the square root of 7 is somewhere between 2 and 3. It's 2 point something. Now, a polynomial can be classified by the number of terms that it has. So, a monomial has one term. So an example of that is 5x. A binomial has two terms, and here's an example of that, 5x plus 1. A trinomial has three terms. So for example, 5x plus y take away 1. If it has more terms than that, we don't get into specific names. We just refer to them as polynomials. In fact, all three of these are polynomials, and there are more. So you could have something that has 4 terms, and that would still be considered a polynomial. Next, we want to talk about the degree of a monomial. This is the sum of the exponents on the variables of a single term. So for example, the degree of 5x squared y is 3. And that's because we have x squared and we have y with no exponent written here, but it's understood to be 1. So therefore this 3 is coming from the sum of the exponents, so it's 2 plus 1. The degree of a polynomial is the highest degree of all the terms in a polynomial. So for example, the degree of x squared plus x plus 1 is 2. And that's because if you take a look at this, term by term, this term has degree 2. This term has degree 1. And this term doesn't have any variables in it, so it has degree 0. Of those three terms, the highest degree of all the terms is 2, and so that's why the degree of the polynomial overall is 2. Next, for each polynomial, we'd like to state the degree, which we'll do in this column. We'd like to state the number of terms, which we'll do in the second column. And we'd like to identify each as a monomial, binomial, trinomial, or other type of polynomial. Alright, so first we have in part A, f plus g plus h. The degree here is, so the first term is degree 1, second term is degree 1, third term is degree 1, so overall this has degree 1. The number of terms, of course, is 3 because there are 3 terms separated by adding. And so that makes this a trinomial. The next one, m squared minus mn plus n squared. If we want to know the degree, first of all, then we're looking at having degree 2 for the first term. We have degree 1 plus 1 is 2 for the second term, and degree 2 for the third term. So overall, this is degree 2. Of course, there are 3 terms here again, and so this is a trinomial. Next we have x minus y. So starting off with the degree, you can see that this term has degree 1, this term has degree 1, so overall it has degree 1. The number of terms here is 2. And finally, we call this a binomial because there are 2 terms. Next, you can see that we have a single term, and in this term we have degree 2. So there we go, degree 2. There is a single term, as I mentioned, and so we call this a monomial. Next we have 31, which is a number. There are no variables, and that explains why the degree is 0 here. It's a single term, and again we call this a monomial. And finally we have degree 2 for this polynomial, and the reasoning for that is that the first term has degree 2. The second term has degree 1 plus 1 is 2. The third term has degree 2, and the fourth term doesn't have any variables, so it has degree 0. Of all 4 of these terms, the highest degree is 2. There are 1, 2, 3, 4 terms here. So we don't have a special name for this. We're just going to refer to this as another polynomial. Next, we want to talk about algebra tiles. Algebra tiles are used to make physical or pictorial representations of abstract things. And so what we'd like to do in this example, now that we know that a positive 1 tile is this little guy here, a positive x tile is this one, a positive x squared tile is this one, a negative 1 tile is this one, negative x is this, and negative x squared is that, we'd like to write an expression that's represented by each set of algebra tiles. So here we have 1, 2, 3, 4 tiles. You can see that this one is a negative x, and these 3 are positive 1s. So in total, we have negative x plus 3. The next one, we have an x squared tile, an x tile, and then 2 negative 1 tiles, giving us x squared plus x minus 2. Part C, we have negative 2x squared because there are 2 negative x squared tiles. It's negative 3x because there are 3 negative x tiles. And there are 4 positive 1 tiles, which gives us positive 4. Last one, we have 2 x squared tiles, and we have 5 negative 1 tiles. So it's 2x squared minus 5. Last example here, so let's consider the polynomial 3a squared minus 4ac minus 8, and we want to state the following. First of all, how many terms are there? 1, 2, 3. Secondly, what is the coefficient of the first term? The first term is 3a squared, so the coefficient is 3. The coefficient of the second term is, here's the second term, the coefficient is negative 4. So don't forget to take the sign that goes with it. The number of variables is 2. A is one of the letters that we use, and C is another one of the letters that we use. 2 different letters, 2 different variables. The degree of the polynomial is, so if we're taking a look at this term by term, you can see that the first term has degree 2, the second term, 1 plus 1 is 2, and the third term has degree 0. So overall, this means that the degree of the polynomial is 2 because the highest degree of the 3 terms is 2. Finally, the constant term is negative 8. So constant term means the term that doesn't have any variables in it, and so this is the term that does not have any variables, and it is negative 8. So that concludes this lesson. Thanks for watching, and have a great day.